Let's take a look at how we can use slope to calculate this problem. So we're given the slope of a wheelchair ramp is 2 over 9. We know that 2 is the rise or the change in vertical distance. So on my triangle here, I'm going to label that vertical height as 2 units. And we know that the run, that denominator, is 9 units. So for every 2 units that we go up, we're going over 9 units. And we're looking for that angle of elevation. We know from previous units of study that the angle of elevation can be found by using a primary trigonometric ratio because, again, this is going to be a right angle. So we have from this reference angle our side opposite and we have our side adjacent. We know that's the tangent ratio. So we can set up the tangent of that angle is the opposite divided by the adjacent. And because we're looking for that angle, that's where we can take the inverse, so second function tangent, and that angle comes out to be 12.5 degrees. And that makes sense because if this is a wheelchair ramp, you don't want an angle measurement that's too steep. So that's one example of where you can use slope to start to solve some problems. Here's the first thing we're going to look at. We're going to take two pieces of information. So we have 1 point on a line, and we also know the slope of that line. We're going to use those two pieces of information to find, in this case, a series of other points on that line. Before we go through the process, I want you to think about how could you approach a problem like that? What would you do? Okay, so the first thing that I'm going to do is I need a starting point. So I'm going to take this point and I'm going to plot it. So I'm going to go over to -3 on the x-axis, up to 2 on the y-axis, and then I'm going to take my second piece of information, this slope, and I'm just going to count. I know I'm going 3 units up and I'm going 4 units to the right. So from this point, we're going to count 1, 2, 3 up, 1, 2, 3, 4 to the right. And then I'm going to put another point right there. And then I'm going to go again. We're going to go 1, 2, 3 units up, 1, 2, 3, 4 units to the right. And I'm going to put another point right there. And we can continue. Now, I want you to see here that this is going to have the same value as -3 over -4 when we reduce it. A negative divided by a negative is a positive. So this also indicates I can go down 3 units and I can move to the left 4 units. So if I go back to my starting point, we can also go down 1, 2, 3 units and 1, 2, 3, 4 units to the left, and I can put another point right there. Once we have a series of points, we're going to take our ruler and we're going to draw a straight edge through them. And because this is a line, we're going to put arrowheads on the end of it to indicate that it keeps going. And that is how we can get the line. Now, if you end up with one point that's not in the right spot, you're going to know because it's going to be sticking out here somewhere off that line. All right, we're also asked to list 3 other points on the line. I just went ahead and wrote the coordinate points in here, but this is what I want you to see. We know slope is rise over run. My rise is my change in y coordinate. And so if you take a look at the y coordinates of these points, you're going to see that we should be increasing by 3 units as we move from left to right. If this y coordinate happens to be -1, add 3 and we get +2. Add 3, we get 5. Add 3, we get 8. This is my change in run, or my change in x coordinate. Moving left to right, we're adding 4 units as we go across. -7 plus 4 is -3. -3 plus 4 is +1. +1 plus 4 is 5. So that's another way that you could get your points. Let's try the next one. Again, we need 2 pieces of information. We're given a slope and we're given a point, and the point is my starting place. So I went and plotted that on here. We're going to rise 2 units. We're going to run 3 units. So from this point, we're going to go up 2 and over 1, 2, 3, and then we're going to put a point there. We're going to go up 2 over 1, 2, 3, and we're going to put another point there. We're going to also go down 2 and 3 to the left because, again, a negative divided by a negative gives us that same positive value, so we can go down there. And we can keep going down 2 and 1, 2, 3 to the left. and I can put another point there. Once you get a series of points, grab your ruler. You're going to put your ruler going through those, and then don't forget the arrowheads have to go on the end to indicate that is a line that's going to continue on indefinitely. All right, it's kind of fun. I'm going to let you try the next one here so you can have some fun too. If you don't have graph paper, just draw an X and Y axes, make a rough sketch of the grid, and then you can go from there. Okay, so we begin with the point. The point that we're given is this 1, -3. And now I'm going down 1 unit, 4 units to the right. So I'm going to go down 1 and then over 1, 2, 3, 4. Down 1, over 1, 2, 3, 4. Now, if I have this slope written like this, the value is the same. We never leave a negative in the denominator. We always move it to the numerator. But this says that I could also go 1 unit up and then 4 units to the left. So from my starting point, I can also go 1 up, 4 to the left, 1 up, 4 to the left, and you'll see that those points still fall on the line. Where this comes up most often is when we're looking at a rate of change. So we know that a rate is a ratio where we have 2 different units that we're comparing. Anytime you're given a question and you're asked to calculate the rate of change, what you're looking for is that slope. So think about some rates that you might encounter. We know speed, distance over time, that is a rate. So kilometers per hour, we're comparing 2 different units, or meters per second are the 2 most common ones you're going to see here. Pay rate. So you're going to be paid dollars per hour or dollars per month if you're paid on a salary basis. So instead of change in Y and change in X, look to see what are you comparing. And again, the units give you a clue. Kilometers is a measure of distance. Hours is a measure of time. So if you're looking at speed, it is the change in distance over the change in time. And when you see this, you need to recognize that that is speed. If you're looking at pay rate, it's how much are you paid over what period of time. So change in rate of pay for that given length of time. This is one of the examples from your textbook. You need to know that anytime you're asked to determine the average rate of change is slope. It's asking for the average because there are points in time where you may be traveling a little faster or a little slower, but in general, if we start at a time of 205 seconds and we end at a time of 297 seconds, we can see over this length of time how much did our distance change. So we know that in order to get the slope, we need 2 points on the graph. They've given us the coordinates of these 2 points. We cannot count the units and say up to, over to. That won't work, because if this is 1,000 and this is 1,500, we can see we're rising 500 units, we're not rising 2 units. So if the scale is not 1, just be aware you're not just counting, you actually do need to calculate this. All right, so I'm going to go over here, and because this is the point on the left, I've labeled that point 1. This is the point on the right. So I'm looking for the change in Y. We already established is 500 meters. And if I start at a time of 205 seconds, end at a time of 297 seconds, that's a difference of 92 seconds. Now we know the rise is the change in Y. So take a look at the Y axis, and we can see that that's a measure of distance, and the units on that are meters. So I'm going to write down here, this is my meters. On the x-axis, the change in x, this represents time, and we can see that the units are seconds. So we're going to fill in here. That is seconds. Now, if someone asks you how fast you run, you're not going to say 500 meters in 92 seconds. That doesn't make a lot of sense. So in this context, I'm just going to divide them. And when we divide them, we end up with approximately, it's going to be about 5.43. That's an irrational number. And again, I need to put some units on this because I have a situation. So the average rate of change is about 5.43 meters in 1 second. And then again, ask yourself, does that make sense? So is it reasonable if you are rowing to go in 1 second about 5 meters? When you do the questions today, for every question you do, I'm going to get you to draw your axes and label them with the units that you're given. It's going to help you identify what piece needs to go where. In question number 7, if you want to maybe grab your textbook and then take a look at this, we know that we have a 75 centimeter high snowbank. So when we begin, so when time is 0, I have a height of 75 centimeters. We are also told that we have a slope of -3. So that means I'm going to go down 3 centimeters in 1 day, down 3 centimeters in 1 day. So every day I'm losing 3 centimeters of snow. So you want to get an idea as to what's happening before you look at what information you're being asked for. This particular question wants to know, what does each point on the graph represent? So this is going to be the starting height of the snowbank. This point down here is going to be when we get down to a height of 0. So it's how long, how many days did it take that snowbank to completely melt? And then each point along here, if we were to go down and over the whole time, it's going to be how tall or how high is that snowbank on any given day. It also wants to know what this slope represents. So again, we know that this is the rate of change. So this is my change in y, this is my change in x. So I am losing 3 centimeters of snow per day.